Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is construct a BST from pre-order traversal. Okay, so in this question we have been given an array of pre-order traversal, and with the help of this array we have to construct a BST. Okay, what is BST? BST is actually the binary search tree. Okay, so we already know all these things. So now we have to construct the BST from the pre-order traversal. So let's go and see how we can do this. Okay, so this is our pre-order traversal. Pre-order. Okay, now like while doing this question you need to know something about pre-order traversal. So what is this thing? So when we start traversing the pre-order now, so the first node which we get is the root node. So the first node is always the root node. Okay, this we already know. So when we start traversing, we always give the call of left side. We always move the left side. Okay, so first we go for left side. So there is 20 and there is also 20. Then again we go move toward the left side and there is 10. See, there is also 10. And then what happened is, now again we start going to left side, but there's no element to the left side. So if there is no element to the left side, then what we do? If there is no element to the left side, then we start moving to the right side. Okay, then we move to the right side. And suppose if there is no element to the right side also, okay, suppose there is also no element to the left side and right side also, then what happens? Then we backtrack. And if there is element in the right side, then what we do? Again we move toward the left and right. Okay, so let's see the movement here. So how we traverse? First what we do? We move toward left side, again left side, again left side, but there is no element to the left. So what we do? We move to the right side. Okay, then again we move to the left, there is no element. Then we move to the right, there is also no element. Then what we do? If both is null, that is if there is no element towards the left side also and there is no element towards the right side also, then what we do? We just backtrack. Then we go move upside and there is no path remaining. Like we have also used left path and also used the right path. Then again we backtrack, we go up, and now what we do? We explore some more path. Like we have already traversed to the left side. Then what we will do? We will move toward the right side. Okay, so again we will move toward left side, again left, there is no element toward left. Again we move to the right, there's no element to the right. Then again what we do? We just backtrack. And then what we do? Right side, there's no element to the right, so again we backtrack and all the paths are explored. Then we move up and then right, left, again move left, no element, move up, again right, left, right, no element, backtrack. This is the behavior of traversal. So the first thing which we know is, we know that first what we have to do? We have to move. Okay, so let's understand the behavior, like how we are going to call it. Okay, so first what we do? We move towards left. Okay, first we move toward left, and if left is not present, then what we do? We move toward right. Okay, then suppose right is present, then again what we do? We move toward left, then right. And the third thing is, if left and right both are not present, then what we do? We just backtrack. Okay, so this is the behavior of the pre-order traversal. So what we are going to do is, we are going to use the left call first, then I'm going to use the right call. Okay, and then again we are going to use the left call. So if there is no element, then what we will do? We will just return it. Okay, So see how we are going to approach this problem. So first what I will do is I'm going to take one IDX, that is one variable which will point towards the first element of the array IDX. Okay, so I'm going to use this variable, then it will always point to the first element. Okay, now I'm going to place this element to the right position. Okay, then I'm going to move towards forward, like IDX will increase when you create this node. Then what I will do is I will increase the IDX. That means now we are going to place this 20 somewhere in the tree. Okay, then again I will place 10, then again I will place 15, then 25. So this way I am going to place the node one by one. Okay, so what I will do, I will create a node. Okay, so the first step is we have to create a node. Okay, so first step is we have to create a node. Okay, and second step is first we use the left call, then we use the right call. Okay, now as we are creating the BST tree, this is a binary search tree. Okay, so this is BST tree. What is the functionality of BST tree? That is range. So this is the most important thing in this question, that we need to take care of the range. Like for example, BST tree is, suppose this is the root node. The range of this node is the left side, all the element towards the left side are smaller than 30. That means the range will be minus infinity to 30. Okay, you can see all the element lie in this range, within this range, like all the element is smaller than 30. Okay, and what is the range of right side? The right side range is 30 to infinity. So all the elements are greater than 30. So this is the range which we need to take care. So what I will do is I'm going to, we already know the first node is root node. First I'm going to create a root node, that is 30. We have created it. Now what I'm going to do is I'm going to specify the range. Okay, so first starting in the starting, what I will do is I'm going to call the function, and the range what in which we will pass is minus infinity to infinity. That means the root node can be lie with in this range. Okay, so this is the starting index. So this is the left range and this is the right range. Okay, so now we are going to construct the root node. So I will read the IDX value, that is 30. So 30 is within this range, so I'm going to create a root node. Now after creating this node, I'm going to increase the IDX. Now IDX will be this. Now what I have to do is I have to place 20. I have to place this node. And what is the range? So let me write the range also. So range will be minus infinity to 30. Okay, the left range is minus infinity to 30. And what is the right range? Right range lie between 30 to infinity. Okay, so all the elements are greater than 30 and all the elements are less than 30. This is the left and right range. So now we have to place 20. Okay, so then what I will do is I'm going to check for the left first. Okay, so is 20 lie in this range? Yes, it lie in this range. So what I'm going to do is I'm going to create 20. Okay, so I will create 20 and attach towards the left side. Okay, so what I will do, I will create a 20, a node, and I'm going to attach with the left side of the node. Okay, because this node lies in this range. Okay, so that's why I'm creating it towards the left side. Okay, then again what I will do, I will increase the IDX by 1. Now the element is 10. Okay, now I'm going to fit this element, this node, sorry. So again, what will be the range? So each and every time we have to find we have to attach the range. So what is the range for this? The range for this is minus infinity to 20. Okay, because all the element which are smaller than minus 20 will be lie in this side, in the left side. What is the range for this? This is important actually. The range for right side is 22. these elements are greater than 20 but smaller than 30, because overall we have to maintain the thing, that is this range. All the elements should be smaller than 30, so this range will be greater than 20 but smaller than 30. Okay, 20 to 30. Okay, so this is the right side call. Okay, so now the next element is 10. So does 10 lies in this range? Yes, it lies. So what we will do, we will attach the 10 towards the left side. Okay, because this element lie within this range, that is minus infinity to 20, is smaller than 20. Okay, so now we have also fixed this. Now we are going to fix this. So again, I'm going to specify the range. So what will be the range? The range will be the minus infinity to 10. And what will be the range for this side? The all the element will be the smaller than 20 and greater than 10. 10 and 20. Okay, so this is how we are going to create the range. Now we are going to increase the IDX. Now the IDX will become 15. So will 15 lie there? No, because 50 is not in this range. So now from this condition you can able to understand what is the base condition. What is the base condition? If the array of IDX is greater than the R. Okay, or else you can also say that if array of IDX is less than this range. Okay, left side left range is greater than the array of IDX. We will understand it why this is a base condition. Okay, later on when we are doing the coding part. So now we have to fit the 15. So 15 will not lie in this range. Okay, so we will check for this range also. So does 15 lies in this range? Yes, it is between this range. So 15 will come here. Okay, so like this way we are going to attach each and every node within their correct place. Okay guys, so let's go and code this. So now I'm going to code this program in Java. Let me do the full screen. So first what I will do is I'm going to copy this method, and now I'm going to change the name of the method. Okay, so let me write the create Bst, and then I'm going to call this method from here. Okay, so what are the arguments which I'm going to pass in this method? That the first one is PreOrder, that is the array, and see we have to pass the two more thing also. These thing, this is the left range and the right range. Okay, and what is the starting value of left range and right range? The first element that can lie between minus infinity to infinity. So I'm going to pass these two things. First is left range, that is minus 1e9. Second one is, sorry, it's not minus, it's infinity, 1e9. Okay, so minus infinity to infinity. So now so this is what we have to do. Now I'm going to create our Bst. So what are the first step which we do? First I'm going to traverse this array. So first I'm going to take this IDX. Okay, so first I will take this IDX value, and this value will be the static. Okay, so let me take one static value, static int IDX, and we'll start with the 0. Okay, so it will start with 0. And what is the next step? So first, our first node is always the root node. So each and every time what I'm going to do is I'm going to create one node. Okay, suppose this is our IDX. So first what I will do, I'm going to create the node. then I'm going to see the correct position of this node. So there is no element in this tree, so this will be our root node, and this also lies in this range. Okay, then what will happen? The second node will be created. So each and every time what I'm going to do is I'm going to create a node, and then I'm checking it, then I'm seeing, so where I have to place this node, then I'm going to see it. First I'm going to check it to the left side. If it lies between the range, within the range, then I'm going to place it here, or else I'm going to check it here. Okay, so let me write it. First let me create the range. So before doing that, I'm going to change the name of ARR, and then I'm going to receive these two parameters. First one is left range, the second one is right range. As you can see it here, the first one is left range, the second one is a right range. Okay, so let us create a node. So create node. So first I'm going to create the node. So how can we create the node? By using the object. Okay, so let me create the object of tree node. And what is the value of the node? The value of node is array of idx. Okay, that will be the value of node. Okay, so let me assign it here, array of idx. And each and every time we have to increase the idx by 1. Okay, so I'm going to increment the value of idx by 1. Now we have created the node. Now I'm going to use the call create bst. First I'm going to use the left call and then the right call. What are the arguments here? ARR, and there will be range. So what will be our range? See, what will be our left range and right range? So first it was minus infinity to infinity, then it was to the, it is the left call, it is the right call. So first I'm going to use the left call. So what will be the range of the left call? So you can see here the left call is left side is minus infinity only. So no, I'm not going to change the LR. Okay, so LR will be the same, but what will be the value of right? Right will be the value of node.data. See, let me remove this. So I'm not going to change the value of LR, so LR will equal to the LR only. And what is the value of RR? RR will be 30. And what is 30? 30 is node.data. Okay, so left range will equal to the left range only. Okay, we don't have to change the left range, but we have to change the right range, because the right range here is infinity and we have to change with 30. That means what will be our left range? Left range will become left range only. And what is the right range? Right range will become node of well. Okay, that is our node, and the value of node will be right range. So I will specify LR only, and right range will become node of well. Okay, node of well. Now again I have to attach this toward the left side. So node.left equal to create bst. So let me copy this same, and I will attach this call toward the right side. Okay, and what will be the value of LR and RR? Okay, see, let me erase it. Now what will be the value of LR? Left range will equal to the node.data, node.well. What is the value of RR? RR will become RR only. Okay, so these are the two values. So let me write it here also. So left range will become start from node.well, and it will end in RR only. Okay, and in the end what we have to do? We have to return the node. Okay, So we have created this. Now the only one thing is remaining, that is base case. Okay, base case is remaining. What will be our base case? See, the first base case is if we have traversed all the element, if we have explored all the element in the array, then we have to return. So let me write this condition first. So if array length is equal to idx, if idx is equal to the array dot length, or what are the second condition? Second condition is, suppose this is our range. So let me first erase this. Suppose this is our range, minus infinity to 30, and we want to insert this value. Okay, so let me take this. We have to insert this array of idx, that is equal to 39. So does we have to check this element, does this element lie within this range? If this lie within this range, then we don't have to return, we have to just simply use the call. We have to attach the element to the left side or else the right side. Okay, and when we have to return, if this array of idx lies here or else here, that is the left side of the left or the right side of the right. Okay, if it lies left side of the left range or to the right side of the right range, okay, in that case we have to return it. Okay, so we have to say it. So first I'm going to check it. So if array of index is greater, if the array of index is less than the left range, then we have to return. If array of index is greater than the right range, then we have to return. Okay, so let me write these two conditions also. So the first condition is if array of idx is smaller than the left range. This is the first condition. If it lies toward the left side, or you can also say that if array of idx is smaller than the left range, then we have to return. Or the second condition is it lies toward the right side. That means if array of idx is greater than the right range. So let me write this condition also. If array of idx is greater than the right range, then what we have to do? We have to simply just return it a null. Okay, then this means it is out of the range. Okay, so let me run this. So we have covered all the points. So let me run this first and check for the compile time errors, and it is accepted. So let me submit this and check for all the test cases. And all the test cases are running fine. Okay, so thank you guys for watching this video, and we'll meet in the next video.